Okay, good evening. Now, this is our 10th week of Statistical Saturday Club, and continuously we are meeting for last 10 weeks. It's almost 2.5 months. And initially we have covered the Excel part. Then now we have moved into the our important aspect of statistics. And in last 2 weeks, we have covered some basic intuition of statistics, how we can go about it. So today also we will try to build on our probability theory. So we will look at the short recap, and then we will look at the conditional probability. That what is the conditional probability theorem. Maybe we will not cover today our base theorem. We will see if it is time permits, we will do that. But we will introduce for sure the random variable and probability mass function concepts. And then we will move into our practical applications of all these concepts, because in and around we might have learned these all concepts in our school or in college, but how we can practically implement them in our studies, that is the main our importance of this session. Okay. So just recap. So last session, as we have seen the permutations and combinations. So these are actually the building blocks for our probability theory, and we have seen that the permutations, the order is not matter, and in combinations, order does matter. So the formula we have seen is very simple. It is just n factorial divided by r factorial in case of permutations, and in case of combinations it is n factorial divided by r factorial and n minus r factorial. Okay, I will just try my different color so that it will be more visible. Yes, so red might be okay. Okay, then we have seen many things, like we have seen the function. What is the function? And function is very simple thing. We have seen that function is something which has three parts. It has input, then it will do some process, and it will have the output. Okay, so these three parts are mainly done by the function. And today in this our session, we might learn that why the function concept is necessary for us in the probability theory. So that part will be there. Then we have seen that there are relations between the variables. So we have seen this graph. So if this graph exactly grows in 45 degree, if this is 45 degree graph, 45 degree, we have seen that this is the graph of function f of x is equal to actually x. F of x is nothing but y is equal to x, because here we say that y is dependent variable and x is independent variable. In that case, it is the just directly proportionate. So if here x increases by 4, the y also grows from 0 to 4. That is what we said about the direct proportional. And indirectly proportional or inversely proportionate graph would look something like this. So when my x is increasing from 1 to 3, but it is increasing from 1 to 2, in the same case my y has been decreasing from somewhere around 5 to somewhere around 3. As x is increasing, y has been decreasing. So this is what we have seen, some basics parts which will be required. Then we moved into the our probability theory. So we have seen there are some 4 axioms of the probability theory. Can anyone recall that what are the axioms of probability theory? we have axioms means rules also, you can say, just defined rules, set of rules, while we are dealing with probability theory. Can anyone recall it?
Probability is not more than 1, or it's 0 to 1.
Yes. So,
That I can't tell that like P of S is equal to 1, or uh, P of A plus P of B is equal to uh, like that. I forgot, but I know just basic
no. So
4 rules.
you are correct. You just I will put in the clear words that suppose I define that A is my event, any event. Okay. The probability of that event cannot be less than 0 and cannot be greater than 1. It will be always between 0 and 1. So like here event, what I mean by event, I cost a time. This is my experiment. Okay. This is very example, wherever in all textbooks you will see the coin toss. Sorry, this is N. Coin toss. And this is my experiment. What I am saying as my event is the coin faces head. Okay, so this is my event. So this is just example, so that for any event I can define n number of events on this simple experiments also. But just but the probability of any of the event cannot be uh, greater than 1. So it must be between 1 and 0. Okay. What else we have seen? This is the one, that probability between 0 and 1. Anything else? Can you remember about what we see about the probability?
Yeah, probability of A plus B is equal to probability of A plus probability of B, and probability of whole sample space is equal to 1.
Okay. So we'll take these two. So first, she said very rightly that probability of uh, S is always equal to 1. Correct? So that probability of my whole sample space here, the in coin toss, what is my sample space? It either can be heads or tails. And if I ask if this is my S is equal to head and tail, what is the probability of yes, this is greater S, it's always going to the 1. And what is my sample space? What is mean by sample space?
All possible outcomes.
Yes. So list of all possible outcomes. Whatever all possible outcomes I can have. Suppose I have the experiment that I'm going and asking a person, what is your income? So it might range from 0, 1,000, 5,000 monthly income to up to like Ambani's and etc. They will have in crores or billions. So that all possible answers are my sample space. So in some experiments, the sample space is going to be infinite. It is never ending. Like I'm going to select randomly a number. Selecting a random number is my experiment. The sample space is infinite because it is go on and on and on. I can select 1 crore like that. Okay. So that difficult part we will not see here. Just we need to remember that probability of whole sample space is going to be 1. The second, we have seen that if event A and event B are mutually exclusive, correct? This is condition. This is what we saw. If this is our sample space and this is my event A and this is my event B, then probability of A and B is equal to probability of A plus probability of B. Okay. Anything else? Are we missing out anything?
Yes, if we know one probability, like probability of A, so probability of B or probability of like it's a 1 minus the probability of A.
Yes. So it is about the complement. So we are having one. This is my this is very shorter. Just okay. So if this is my sample space and it has exactly two parts. Okay. My event A and this is my event B. Only two. So what is the probability of this whole sample space? It's always going to be 1. Then if I calculate for my probability of A, I will get something from what is my axiom number 2? It should be from 0 to 1. It cannot be greater than 1 or less than 0. What else I'm saying that I know that this is the probability is equal to X. Something probability is there. I know this probability. I want to know what is the probability of event B. In that case, how can I find? It is simply probability of B is equal to 1 minus probability of A. Many a times, this probability of B is also called as probability of A complement because this is complements, completes the whole picture. So this is the event B is a complement of event A. Okay. So if I know other possible events probabilities, I can calculate for the remaining one. Okay. So these were our axioms of probability. Now we will move forward to our this week. So this is the basic rules we have keep in mind to be successful in our future endeavors. Okay. So now here we will see, here is a problem you all can solve with pen and paper or some very easy problem, that there are 4 students. This is the TD example. There are 4 students from West Bengal, 2 from Tamil Nadu, 2 from Maharashtra, 1 from Andhra Pradesh and 1 from Bihar. So in total, I guess if I'm not wrong, it is 10 students. Okay. Correct? 4 plus 2 plus 2 plus 1 plus 1. Okay. So in TDA batch, this is the student. Now I am asking a question that what is the probability that if you select a student randomly, he or she is either from West Bengal or from Andhra Pradesh? How to calculate that? Our in our axiom, we have seen one axiom about this mutually exclusive event. In this case, I can take this is my sample space. See, many times if you are getting stuck with probability theory or many calculations, calculating, drawing it on the board or the paper much gives us much clarity. So this is very simple example. You can solve by your even just intuition. But I'm drawing because you will get visually how it is happening. So here 1, 2, 3, 4 and 5 actually I'm having the boxes. So this is my box number 1. This I can have 2. This I can have 3. This is 4 and 5. So actually here I'm having 4 students from West Bengal, then 2 students from Tamil Nadu, 2 students from Maharashtra, 1 from Andhra Pradesh, 1 from Bihar. Okay, so I have drawn one extra box. This can be my sample space. And what is the probability of this? This sample is equal to 1 probability. Now I'm asking, what is the probability of student if I select randomly, he is from West Bengal or from Andhra Pradesh? 4 and 2. How to calculate that? So probability of WB
4 and 1.
or probability of AP is equal to probability of WB plus probability of AP. Okay, whenever you are getting or, you match it with sign plus. Whenever you are getting and, you match it with multiplication. Okay, so this is the rule of thumb. So if you get confused, if it is saying that or in your problem statement, that means you can do the addition. What is the probability of West Bengal? So it is 4 by 10 is equal to 0.4 plus what is the probability of AP? It is 0.2 because there are 10, 2 divided by 10 is equal to 0.2. Okay, so total probability
1 divided by 10.
Huh?
1 by 10.
Okay, sorry. So I'd taken the wrong number. I'd taken the okay. So not this, but this, and this is going to be 1 by 0, and this is going to be 1 divided by. Okay, okay. So I will get 0.4 plus 0.1. Okay. So probability of WB or AP is equal to 0.5. Are you clear about this? Anyone having doubt? Anyone can say no. That will be fine.
Yes, clear.
Clear. Okay. This is very simple. We all are doing up to this. It is clear. So now it is the case where you can use your Venn diagrams. I'm having the non-mutually exclusive events. Okay. So now I have just modified one example. You see, there is an NGO, and the NGO has invited applications. NGO, because of its prior experience, they know that there is 0.5%, 4% probability that applicant will have 5 years of experience. Okay, so if there are 100 applicants are applying, in many a case, approximately 40 are having 5+ years of experience. Okay, and within this 100, there are 70 applicants which are having a quality education in the sense from a recognized university and good university, they are having education. But 0.3, only 0.3% probability is there that the person will have both 5 years of experience and quality education. So in these 30 students, 30 applicants many times are having this both. So now here the question has been asked, what is the probability that the applicant will have either experience, so here assume 5+, or quality education. So now how to calculate this part? So in this case, our events are not mutually exclusive. What is I mean by, you see, if I draw, this is my sample space. If I draw a circle here, if I draw circle here, so this is going to be my right drawing for this example. This will not going to be mutually exclusive. This is my event of experience. I will write EXP, and here I will write edu. And here I am having the intersection. For the experience, for this whole circle, I am having probability 0.4, for this whole 0.4, and for this whole education I am having 0.7. So if I do my normal math, that probability of A and probability of education, probability experience, the total will come 0.4 plus 0.7 is equal to 1.1. And that is not case, that the probability of having applicant is greater than 1 is not possible. That means we are doing something wrong. So what wrong we are doing? We are double counting this portion. We are counting here also, we are counting here also. So that part we need to minimize. So just for your those who at least studied the high school level set theory, they know that A union B is equal to A plus B minus A intersection B, right? You might know this and did many a times. So this is what we are also going to do here. So it is like the experience 0.4 plus education 0.7 minus what is the intersection? It is 0.3. That's why it will count 1.1 minus 0.3. It will come around 0.8. Okay, so in case of, because these are very simple examples, I know that you are going to be very clear about it. I just want to mention that in this such examples, you need to check that whether that events are mutually exclusive or they are not mutually exclusive. So you need to be very careful while talking about the events, because probability theory is based on the events. Many a times you will deal with only events. Okay. So now we will move to the conditional probability, because it is very related that once you are having some given, like in this case, these are some interactions are happening here, then I can ask some conditional questions. So I will come to the conditional probability. Now, here I have given some questions that will clear that why conditional probability is needed. Okay, conditional probability is required because you see, if this is typical questions you will face in development sector, that you might go for the survey, you will collect the data, socioeconomic data, you will collect the gender, and income data you will collect the monthly or maybe their annual income. So in that case, if I have collected the data and I'm having the gender details and I'm having the income details, so I'm not only interested that how many female or male are there, what is their probability of male. So this is my first event. This is my first event, is that what is the probability of male? This much only question I can ask. This much we have seen in last session. Here we are dealing with multiple events today's session. So this is first event. That's why I have highlighted with a yellow mark that a person is male. This is first event. But I'm not interested only in this event. What I'm interested in is that further that this is has been given. I know that the person is male. Now I'm asking that what is the probability that he will have the income more than 5,000 rupees. I'm interested that what is the, here you can ask multiple questions. You can ask the person has given that it is he is a male from SC caste, he is a female from SC caste, he is a person in below poverty level. Okay, so this is the questions we are interested in, because we want to do some socioeconomic analysis to do some social interventions. Another question can be have a person has age 27. It has been given, you know that for sure. So what is the probability that he or she will die this year? So those who are in doing PIM course, postgraduate diploma in insurance management, or those who are dealing in their real life, those who are professionals, they are handling some insurance related work, they might have this question because they want to create a product based on this probability, that the person who is you can have the range also, for the problem sake I have given. So what is the probability in a particular area that for age 27, what is the mortality rate in 7 years, or what is the rate that he or she will die? Because based on that you will have your product for your premium, you will calculate on based on that. Or someone is working in FPO management, so he or she might have some question like the I have given with a farmer. I know that the person is farmer, has 3 acre lands. So I know that the person is farmer and he has 3 acre lands because I have collected the data. So now what is the probability that he or she will have? She will cultivate the ragi here. This is my question, because I'm having a PO. I know the data about the farmers. I want to predict that how it is going to be, he or she is going to cultivate the ragi or not. So last one question. Until this, it is okay. Now you see my last question, that given today is Monday, I know that today is Monday. Okay, this is for example sake, or you can say that today is some Saturday, because our Saturday statistical curve. What is the probability that it will rain? So this question is different from all about these three questions. And can anyone tell me that why it is different from all about these three questions? Can anyone tell me?
Hmm. There is no quantitative data or specific data, I think.
Okay, so we will first say that there is no data available. Anyone else? Anything? What? How it is different?
Means how we will calculate it.
So there is difference in calculations. See, but nowadays what is happening? You are getting the day-wise data for last some few years, that when it is going to rain. So data is available, that last Monday it rain, Tuesday it rain, Thursday it rain. Okay, without stretching too much, just I want to mention one thing, important thing. Yes, other things can be there, possibility about the collection of the data is needed, empirical data more required in this modeling. All these things can be inferenced, but important thing here is there is direct dependence from here, because see, in the rural sector, mostly the male will handle the money. So in the case of income, I can ask these questions. Age and mortality is directly connected. So if age is more, mortality will higher. If age is less, mortality will be less. That is what connection. So we know that the small farmers, we call the small and marginal farmers, as the land grows, as the assets grows, they will tend to the cash crops. So this is what we know, because intuitively we know, but there is no such any dependence from Monday and rain. So conditional probability. So when you are thinking about the conditional probability, you need to think about one important concept of independence or dependence. Whether that event, what is second event, like the first event is that the person is male, the second event is that income is more than 5,000. So whether that event is directly or indirectly uh, dependent on my first event. Yes. So we were talking about this. Whenever we are thinking about the conditional probability, the dependence or interdependence is what we need to think about. Okay. So this tends to our next part of how to check this dependence and independence part. So now here again we will have, because see, statistics is part of mathematics. You cannot run out of the problems and calculations. So that you need to always have something in mind, and you need to do the calculation. So that's how we will do a whole part of probability. So now we have, you have rolled a dice. Dice, you all know that six parts, six faces it has, having 1 to 6. And what is the probability that it will show the number 3? Can anyone tell me with calculation, what is the probability that I will get number 3? What is the probability? Am I audible? Am I audible? Aditi, Akshay. Amit, yes.
Yes.
Okay. So how we are doing that? We know that first we need to calculate what is the sample space. What is the sample space here? How many possibilities are there? Total 6 possibilities. 1 to 6. Correct? Am I right? Dice has 1, 2, 3, 4, 5, and 6. Correct? This is my sample space. Now, how many possibilities are favorable in my event? Favorable event. So, what is my event? The number, it will show number 3. So, there is only one possibility that is favorable for me, and all are having equally likely chance. So, all events are equally likely. Randomly, we know that the dice is fair dice. So, it will have equally likely outcome 1 by 6. So, the probability of one dice is 1 by 6. Okay, up to there very clear that it is 1 by 6. Now again what I did, I have rolled the 2 dice. I have rolled the 2 dice at simultaneously at a single time. I have thrown 2 dice. So what is the probability that the second die will show number 3, given that my first die has rolled the 6? Now the problem has been changing. Are you getting my point? What the question I'm asking? Okay. So it's so Amit is saying 1 by 3. Okay, but Amit, are you clear about the question? That I'm asking about the 2 dice. Okay, so first dice has already rolled 6. Now I'm second dice I'm rolling. What I'm telling you that the first dice and the second dice have any connection, because I rolled the first time, it has came the 6. The second time when I'm doing, it will have some certain number of event, because it is can you say with surety if there is any need that you will get that number only? So these two events, rolling these 2 dice, are totally independent. Whatever you do first die, you get 1 or 2 or 3 or 4 or 5 or 6. I don't worry about it, because in the here I will again have option to get 1 to 6 with probability every event having 1 by 6. Okay, so the probability that the second die will show number 3 is again 1 by 6. Okay, because these are independent event. Getting my point? These are independent. There is no. But now you see the third example. Third example we will not calculate, but just for the intuition, I'll give that this is the example of dependence. So now you have selected a random person from village. So now I'm asking question that what is the probability that person is poor, given that he owns a car? So I know that I go into a village and I saw some person. I got get to know one person, and I know that now he owns a car. He has a car. What is the probability that he is poor? Right? So owning a car changes the dilemma, because we know that if he owns a car or more resources, that does means that he will have less poverty. Okay, so that's why dependence and independence are required. I will just give you uh, Now you see how to statistically say that two events are independent. This is just a rule. You can remember, or you will get to the internet. Just for our sake, we are saying the probability of event A and B is equal to probability of A into probability of B. Then we can say that these events are independent events. Okay. When we increase the number of events, like event A, B, C, D, in that case the scenario changes. So we will go over there. You need to check every event's independence in that case. Just for a rule purpose, I'm saying you that you can remember this. Probability of A and B is probability of A into B. If that is the case, means that two events are independent. Okay. Are you clear, or I'm going fast, or something is vague? Please give me something. Yes, Priya. Okay, thank you. So until now, this is clear that what is dependence, independence. Okay. Now we will move directly into the conditional probability on toy experiments. Just okay. We are having 9:30. See, I have missed one important part on the conditional probability, that it should be have dependent, but one more important part in conditional probability, that how you will calculate that. So we mostly say that probability of A given B. So given B is the event which has occurred. So what if the event B has occurred? Probability of A I want to calculate, and this is equal to probability of A B divided by probability of B. This is the formula. So just we need to remember this formula whenever you are calculating the probability case. See, this formula is actually very relevant to the formula when you draw a Venn diagram. So what I'm asking, that the event B has already happened. What is the probability of event happening A? And what is the probability? That probability just only this red part. I'm drawing with little small part here. What is the intersection part? That is only probability, because if B has happened only for this favorable outcomes, I can have the probability. And this is what we are doing. Probability of A and B is gives this part, A and B, correct? Right? A and B. This is two parts happening together, divided by this whole part. Probability of, might be I will draw some different color. Is it visible properly, or I'm drawing something small? Is it visible what I'm drawing? Yes. Okay.
Yes.
Thanks. Yes. Thank you, Priya and Amit. So this is the intuition. So you need not to remember this formula. How this formula has arrived, you can yourself derive this formula using this simple our visualization tool, that probability of A, probability of B, probability of A and B. So probability of happening the event A is actually there, and that's why when we said independence, in the case of independence, uh, the events will have no intersection point. In this case, you will not have this will become 0, correct? Plot A and B will become 0. So 0 divided by something is always coming to be 0. So that if person is male and female, these are totally independent events. I ask that selected person is male, female. What is the probability that person is going to be male? So this is a very ridiculous question, because if I already know that person is a female, I'm knowing for sure that the person is male is not going to happen. So this will become 0 divided by whatever the probability of female, it is 0.5, and it is going to be 0. This part is clear. What is conditional probability? Any doubts? Anyone having any doubts in conditional probability? Because we are going to now solve some examples and look this definition in detail. Okay, so I will assume that you all are clear about this, and so we will move to our further part. Oh my God. Okay, so now we are having a question that you have rolled a die. This is toy experiments we are going to solve. So what is the probability that it will show number 3? We have seen that it is 1 by 6. So now we are having the conditional probability question, that if I know that what is the probability that the second die will show number 3, given that the first die turned 6. This is what we have seen in the next part, our second part, and this is we have calculated as this is independent, it is also going to be 1 by 6. Okay, so now this is the another part. Now we have changed the question. You have rolled two dice simultaneously. So now what is the probability that both dice will show odd numbers, given that the first die turned the 3? Okay, so now this is the interesting question, that because I need to know that whether it is going to show the both dice will show the odd numbers. Okay, so now what is by event probability? So here instead of writing A and B in initial stage, until you get clear with these notions, you can write whole. So that probability of both dice odd, this I am writing short, given this symbol is called as a given. So below I will write this symbol is says in given. So in many textbooks you say that this is given. So both dice are given that the first dice turned a 3. What is the probability? So in this case, we will suppose this is our event A and this is our event B. So we can write our probability like, what is the rule? We have said probability of both dice odd and first dice 3 below, divided by probability of B. What is the probability of B? It is probability of first dice is getting 3. Now we will calculate this each event. So what is the probability that both this dice will get odd number and also the first dice will get 3? So here we got the first dice as 3. How many possibilities are there? We are having 3, 1. Second dice might get 1. 3, 2. The second dice might get 2. 3, 3, 3, 4, 3, 5 and 3, 6. So total how many possibilities are there? 6 possibilities. Correct? But what are the favorable? Because both should be die and first should be 3. So first is 3 and odd, this one. Second is not. Third is favorable. Fourth is not. 3 and 5 is favorable? It's not. How many are there? Only 3 out of 6 are favorable. So what is the probability of both dice odd and first dice show 3 is 3 divided by 6, right? Am I right?
Yes.
Yes. So what is the probability that first dice shows the 3? It is 1 by 6, correct?
Right.
I think we are doing something wrong over here. We'll just we'll recalculate this for
Both dice should be
uh,
odd.
yes. So now uh, here we will calculate with our another the rule of probability of A and B is going to be probability of A times probability of B. So what is the probability of both dice odd? Both dice odd is 1 by 2. This is what we have calculated. Correct? This step we have missed. Both dice odd is we calculated 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Total 6 out of that 3. That's why it is coming both dice odd is 1 by 2. But the first dice 3, that also event should happen, and that is 1 by 2 into 1 by 6, which comes together 1 by 12, correct? So this step we have missed to calculating AND part, okay? Because there are total, I will just clarify you, total 1 comma 1. When we do the sample space, what is our sample space for two dice? 1 comma 1, 1 comma 2, 1 comma 3, like that up to 6 comma 6. How much possible outcomes are there? 6 into 6 is equal to 36. So what is the probability that both are odd in that case? And first is 3. In that case, first is 3, I need to have 6 outcomes, and both are odds are having 2 outcomes, and that's why it is happening 2 divided by 36, around 3 divided by 36. 3 outcomes will come because 3 1, 3 3 and 3 5. So 3 divided by 36, which is coming to be 1 divided by 12. Clear what I missed? This AND part. Okay, so this is my first event of this. I will just change my color so that now you will understand. My first is that both dice odd and first dice 3 I have calculated using formula P times A into P times B, and it is coming 1 by 12. Now what is probability of my second event? Probability of dice facing 3, it is divided by 1 divided by 6. So divided by is we will do just inverse multiplication into 6 divided by 1, which will come 6 2s are 12. So it will turn around 1 by 2. So what is the probability that both dice will show odd numbers given that the first die turn 3 is equal to 1 by 2? Okay, is everyone clear or having some doubts? Clear what I did, how I was doing? Everyone is clear?
How you got 1 by 2 for both dice odd? Is it 18 by 36?
Just I will do in this space. Okay, this first event, what is the probability we have calculated? 1 by 12, correct? right?
Yes.
Yes. So this is 1 divided by 12 divided by, what is this probability? First die will face 3. It is 1 divided by 6.
No, no,
Correct?
no. I'm not asking last question. I'm asking first that 1 by 2 into 1 by 6, you got 1 by 12. So that 1 by 2, how you got?
Yes. The both
Uh,
devices are odd. Dice is odd. Correct? This is my
yes,
event,
yes,
correct? Event.
yes.
So now I will do here again to showcase you. So I will just take some labor to get you all. See, what is, if I roll a dice, 2 dice, correct? What is my sample space? My sample space is,
36.
I will just write this 36. 1 comma
So
1.
in that 36, there will be 18 odd. 18 by 36. So in that way, you calculated 1 by 2, or is there any other way?
No, no. But how you calculated this? See, here will be 1, 3 and 5. These are 3 outcomes. Yes,
Right,
correct?
right, right.
Here again I will have 1, 3 and 5 outcomes. So it will be coming 9 divided by 36. Correct? Oh, 1 to the 4. Just wait. What we are doing now? You are right. This 1 by 2 is our problem.
No, it's right now.
What?
We will write those all 36 options. Then we will get 18 by 36. Then it will be 1 by 2. As per my understanding, I don't know which logic you used.
No, no. See, this is correct. This is for
Both
your
dice are odd
whole.
means there will
No,
be 18
no. This
conditions,
this is for
18
whole.
chances.
This is whole part we have did. For answer, your 1 by 2 is correct. For this whole part, correct? Well, just we need to calculate that both dices are odd and first dice is 3. Got my point? This is whole. For all 36, this is clear. What I am saying that, you got my point? I
Yes,
know
yes.
that this is 3. I know that this event is 3. What is probability that this 2 will all both will have odd numbers? For that 1 by 2, this is method we have did, that is correct. What I am saying that now if you write this 1 by 1, 1 by 2, 1 by 3, up to that now I will write whole only line of 3 because 3 is interested for us. 3 by 1, 3 by 2, 3 by 3, 3, 4, 3, 5. Okay. So 3, 6. So there are total 36 outcomes, but I don't worry about it. I want this because I know that first event has happened and that is 3. Correct?
Yes, sir, that's right. But that's the second case now. You have to just look out on
This is case.
both
See,
dices are odd. Both dices
no,
are odd.
no,
Odd
no,
numbers.
no. And both dice is add and first dice
So,
is 3.
so we will use multiply, right? We will multiply it. 18 by 36 into 1 by 6.
So what I'm saying, you just visualize this. Here you will get 1 by 2. Correct? Are you getting my point?
No, how
And
1 by 2?
this is 6, na total 6.
Uh,
3 out of 6. And the probability
right,
of first die getting
right,
3
right.
is 1 by 6. First die is 3. That part is here.
Yes,
So we
yes.
will get 1 by 12 here. Getting my point? We need to first
Okay.
get here we need to first get this line. That is probability is 1/6, sorry. After getting this line, getting odd is 1/12. Sorry, 1/2. 1/2. Okay. So we will keep on doing multiple examples, so that we will someone is joining or not, so that we will get clarify. Just we will complete our today, because only 4 minutes are remaining. Okay. So now we will just introduce the Bayes theorem. We are missing because we don't have time. We will come to that Bayes theorem. Bayes theorem is just inverse of conditional probability. Here you have seen that the probability of both dice odd, given that probability first dice is 3, we will just inverse ask the question that I know that the both devices odd. What is the probability that first dice will be 3? So we will look at that later in our next session. And next session we will also solve some conditional probability problems, so that we will get clarified. So now here we will just want to introduce what is the random variable. So what is a random variable? We said that our variable like gender was having values like male, female, other, male, female, and other. Okay. So now just I want to make this as a random variable. Random variable assigns some value, numerical value. If it is already numerical, don't no need. But if it is that, in that case, what we are saying, the coding, it will do the, for gender, it will convert it to the 1, map to the 1, 2 will be mapped to the female, and 3 will be mapped to the other. So this will become our the random variable. In this case, now for coin toss, we will have outcomes 0 and 1. It is heads and tails. It will be mapped to the 0 and 1. Or in the dice case, it is having 1 to 6. So this already it will be 1, 2, 3, 4, 5, 6. That will be our random variable itself. So this can be your normal variable or the random variable. Is it clear? What is the random variable? Are you clear about this? I hope that you are clear about this. So now we are having the another concept which just I will introduce in this session. Next upcoming sessions we will start doing some calculation part, and we will start using this. So what is a probability mass function? PMF. Okay. So now here it is important to know what is a probability mass function. It is also simple, that it is calculates the probability that the discrete random variable. So now this probability mass function is defined for the discrete random variable. Okay, this part you don't wonder. What is discrete? We said discrete values have the number like 1, 2, 3. So it will have interval. There is nothing between 1 and 2. But what is the continuous? Continuous will have all values from 1 to suppose 10. Then it can have 0.1, 1.0, 1.5 to up to 9.9999999, and it can have the 10. So this is continuous variable. It takes the values on the interval. So it takes whole interval of 0 to 10. It takes the values. So the probability mass function is defined for the discrete random variable, which is taking the values, discrete values, and for the continuous random variable, it is called the probability density function. Okay, so we will see that later, but for the basics, what we are now dealing with the discrete random variables, where our all the random variables we are taking values like 1, 2, 3, 4, 5, 6, like gender or other. So that up to some extent the education and other parts. So now, what is probability mass function? My PMF of coin toss will be, I'm having not only function, but I will have values with probability. So these are the values taken by the random variable, and this is the probability at which the random variable takes that value. Okay, so the random variable, my random variable of coin toss takes value 1. When it takes the value 1, when it is heads. What is the probability that it will get heads? It is 1 by 2 and heads equal to 0.5. Same is the case for the tails or the tails. It takes 1. I am modeled differently. Tails is taking 0. For 0, it is again taking 0.5. Okay. Are you got clarified about the probability mass function? Clear? Is it clear? Because now
Yeah, not that much. Can you explain it in Hindi?
एक हिंदी, फॉर दोज मैं हिंदी में बता सकता हूँ. प्रोबेबिलिटी मास फंक्शन क्या है? प्रोबेबिलिटी मास फंक्शन डिस्क्रीट वेरिएबल का होता है. हमने पहले ही सेशन में देखा था कि वेरिएबल दो प्रकार के हमने मेजरली किया था कि एक क्वांटिटेटिव वेरिएबल डिस्क्रीट हो सकते हैं या फिर कंटिन्यूअस हो सकते हैं. फिर हमने रैंडम वेरिएबल में क्या देखा कि ये जो डिस्क्रीट जो क्वालिटेटिव रैंडम वेरिएबल है जिसका जेंडर मेल फीमेल है, उसको हम कन्वर्ट कर रहे हैं क्वांटिटेटिव में. करेक्ट? हमने इसको क्या किया? कन्वर्ट किया. ये वैल्यू क्या ले रहा है अब? 1, 2, 3. ये कौन सा हो गया अब? ये क्वांटिटेटिव हो गया. करेक्ट? क्वांटिटेटिव में ये क्या हो गया? ये वैल्यूज ले रहा है 1, 2, 3. ये 3 ही वैल्यू लेगा. करेक्ट? तो ये डिस्क्रीट है या कंटिन्यूअस है?
डिस्क्रीट.
तो डिस्क्रीट रैंडम वेरिएबल्स है जो कंटिन्यूअस है, जैसे मैंने बताया था आपको, हाइट वगैरह वगैरह, वो छोड़ दो, अभी डिस्क्रीट पे फोकस करो. सो जो डिस्क्रीट रैंडम वेरिएबल है हमारा, उसका जो ईच वैल्यू है, देखो समझो, अब जेंडर का ही एग्जांपल ले लो. नाउ मेरा जेंडर है और ये समझो इंडिया में 50-50% दोनों है. ओके, 50% मेल, 50% फीमेल. इस केस में मेरा क्या हो जाएगा? अगर मैं रैंडम वेरिएबल लूं, ये रैंडम वेरिएबल मेरा कौन सा वैल्यूज लेगा? इधर 1 और 0. यू कैन मॉडल इट एज 0 और 2 ऑल्सो यू कैन मॉडल. ओके, कौन सा वैल्यू लेगा? 1 and 2. ये हो गया मेरा रैंडम वेरिएबल. रैंडम वेरिएबल में मैं एक चीज ऐड कर दिया, उसका प्रोबेबिलिटी. ये 1 का प्रोबेबिलिटी क्या है? व्हाट इज द प्रोबेबिलिटी दैट द रैंडम वेरिएबल कैन टेक वैल्यू 1? सपोज 50-50% इट विल टेक विथ प्रोबेबिलिटी 0.5. समझो कि हमारा जो सेक्स रेशियो है वो चेंज हो गया. ये है 40% मेल्स है और 60% फीमेल्स है. इन दैट केस ये एक जो है हमारा मेल, ये बन जाएगा 0.4 एंड फीमेल विल बिकम 0.6. अगर आप मुझे ये दोनों चीजें बता देते हो, क्या बताया मैंने? कि मेरा रैंडम वेरिएबल है, वो कौन सी वैल्यूज लेता है, जैसे कि 1, 2, 3, और वो किस प्रोबेबिलिटी से लेता है. सो आई विल डू वन मोर एक्सरसाइज फॉर यू. सी, आई एम हैविंग द रैंडम वेरिएबल ऑफ डाइस, ये डाइस का वैल्यू देता हूं मैं, वो क्या वैल्यू ले सकता है? रैंडम वेरिएबल ऑफ डाइस रोल, यू कैन टेक वैल्यूज फ्रॉम 1, आप ले सकते हो या 2 या फिर 3, 4, 5, 6, करेक्ट? ओनली 6 पॉसिबल वैल्यूज।
Yeah.
इतना मैंने बता दिया आपको, तो ये आपको पता हुआ दिस इज माय रैंडम वेरिएबल। ये तो मुझे पता हुआ कि भाई ये 6 वैल्यू लेता है, ये मेरा डिफाइन हो गया, दैट उतना मुझे क्लियर हो गया, ये हो गया मेरा रैंडम वेरिएबल। ओके, ये बस मैंने थोड़ा ऐड कर दिया उसमें कि मुझे बस वो क्या वैल्यू लेता है मुझे मालूम नहीं होना चाहिए, मुझे ऑल्सो आई वांट टू नो दैट व्हाट विथ व्हाट दैट वैल्यू, उसकी प्रोबेबिलिटी क्या है। ये एक वैल्यू लेगा, ठीक है, लेकिन क्या प्रोबेबिलिटी है एक वैल्यू लेने का? 1/6। व्हाट इज प्रोबेबिलिटी दैट 2 is 1/6, 1/6, 1/6, 1/6, 1/6। अगर मैंने ये आपको बता दिया कि आई हैव वन रैंडम वेरिएबल कॉल्ड डाइस रोल और ये वैल्यू लेता है 6, 1 to 6, and it has probability, it will take the value 1 with probability 1/6, 2 with 1/6, 3 with 1/6, 4 with 1/6, 5 with 1/6, and 6 with 1/6, then it becomes my probability mass function, or we in short form we call PMF। ये क्लियर हो गया?
Yeah, yeah. Now clear.
Now everyone is clear about this? Yes. So हम पीएमएफ क्यों इंट्रोड्यूस, मैं इतना उस पर जोर क्यों दे रहा हूं, क्या जरूरत क्या है ये सब करने की, क्या जरूरत है? जितना आसान था उसमें भी हम कर सकते थे, लेकिन अब क्या हो जाएगा जैसे आप आगे बढ़ते जाओगे प्रोबेबिलिटी थ्योरी में, तो जस्ट तो आगे जाने के आपके जो क्वेश्चंस हो गए, मतलब आपको जो कैलकुलेशंस हो गए, वो आप सीधा पीएमएफ में कैलकुलेट करोगे। ओके, सो समझ आ गया मेरा? आई विल ओनली टॉक दैट आई एम हैविंग रैंडम वेरिएबल ऑफ इनकम, it will have the range from 1 to 106, and I will tell that it is PMF, it is having PMF with 1 into what is my income divided by 10,000. Values are from 1 to this is 10,000. At max it is taking up to 100. So what I am doing, I will not tell you everything, मैं आपको सभी नहीं बताऊंगा, I will not tell everything, I will just tell you that the probability mass function I can directly convert. What is the value it is taking? It is taking value 1. So I will just convert it by 10,000. It will give me the probability of that function. I will just explain in your further question. That's why we have learned what is the function part. So that's why it is important. What it gives, it takes the value, what is probability mass function is doing, it is taking the value of that function, might be not visible because of, yes. So what PMF is doing, PMF is simply taking the value, doing some calculations. So I have said that value divided by 100 into 3 divided by 2, ये मेरा सीधा देगा उसका probability क्या है, what is the probability of taking that value. Okay, so अभी आपको थोड़ा complicated लगता होगा, लेकिन what I want to explain that when the number of your outcomes are growing larger and larger, you cannot tell me for this, you cannot tell me 1, 2, 3, what is the income, possible income? It has range from 0 to 90,000, correct? So I cannot write 1, 2, 3, 4 up to 90,000, and with probability 0 is 0, 1 is 0, up to 10,000 it is 0, then it is growing. So in that case, my probability function can be like this. Suppose PMF of val is defined with this big bracket. From 0 to 10,000, it is 0. From 10k to 50k, it is 0.125. And from it is 50k to 90k, it is 0.875. Okay, so this is what I will just explain you as my PMF. So it will take values for this function up to these values with this probability, this probability. So this will become very easy while we are running with multiple events, modeling that in Excel part. We will just next session, because we are running out of time, we will just see in next session also that how to calculate in Excel. I hope that this part is clear for you. Shall we stop here?
Yeah, clear.